Drum scanners suck. I'm sure if you know anything about scanning film, you've certainly heard endless praise about drum scanners and their capabilities. But are they really all that they're cracked up to be? Do they really make the best possible scans you can get? This video will probably piss off the 10 total people in the world who own drum scanners, but it's the hard truth. First of all, what is a drum scanner anyway, and why is it supposedly so good? Drum scanners are really simple machines in theory. It's basically a lathe, but instead of a cutting tool and a material stock, it's a microscope and a glass tube, otherwise known as a drum, that film is mounted to. But the drum isn't what makes these scanners so special. Like, you could have any scanner that mounts film to a glass tube, but it isn't really going to be a drum scanner. Looking at you, virtual drum scanners, you're just riding the coattails of the name. Real drum scanners are special because of their quasi-analog image capturing system. Inside the drum is a light source of some kind. The light travels through the film and into the microscope. From there, the light is split into red, green, and blue light, which is then sent into photomultiplier tubes. These are kind of like the image intensifier tubes found in night vision goggles, but instead of a whole image, it's just amplifying a single dot of light. Drum scanners use these photomultipliers to convert the intensity of incoming light into an analog electric signal. The amplification aspect isn't really what's important. It's really the conversion of a light signal into an electric signal. That signal is then sent through an analog to digital converter and then onto a computer. Sometimes the scanner itself does some image processing, and sometimes the computer handles it all. Drum scanners are actually technology from the 1950s. Back then, these machines were usually more of a scanner recorder. They did direct enlargements onto bigger film in real time, line by line. Eventually, new models added computerized storage and manipulation systems. These things were all built incredibly well, mostly by German companies, so they ended up costing quite a lot. Drum scanner technology peaked in the late 90s, and then shortly after that, completely vanished. You may think, surely there's a modern drum scanner, right? Nope. The absolute newest drum scanner I could find was made by Aztec in 2003. You're telling me that the technology really stopped progressing and that 20 years later there's still a big gap in the market, especially now when there are more people shooting film at a high skill level than ever before? You're really gonna tell me that 20-year-old technology is the best we have for digitizing film? This is one of the key factors in why drum scanners suck. It isn't because of the physical image capturing process. That almost fully analog process should theoretically be able to capture an extremely high resolution with nearly perfect color. The reason is the technology just stopped improving. A big problem with drum scanners is that the machines are made to be used with computers from the 90s, back when a 1 gigabyte file would fill up an entire hard drive. A scan of an 8x10 black and white negative at just 6400 DPI would end up being around 6.5 gigabytes. Now, there is absolutely nothing wrong with using old technology if it works. Hell, if it wasn't for tech companies artificially bloating software and websites so much, I'd say most people could function with Windows XP era hardware and software. My car is older than the newest drum scanner. I still use iOS 10 on my phone. I am vehemently against updating, especially when the only one who benefits is a big company that wants more control over me and my devices, and in return, all you get is the lie known as security. Anyway, how is it that no new drum scanner has been made? I'm sure analog to digital converters have gotten way better. I bet the mechanical control systems that these scanners use could be much more precise and accurate now. High precision manufacturing is easier to do than ever before. The optics now are better, cheaper, and the extremely small apertures a drum scanner needs could be made even smaller, thus resulting in a higher resolving power. The memory and other computer chip aspects are faster and better, and the software that the drum scanners interact with could be significantly improved on. And how about just new ways of mounting film to the drum that's easier than before? It's a real pain in the ass to actually get the film on the drum and have it be perfectly lined up. No one wants to deal with that. But these are just surface level problems. Really, you don't want to dive into the absolute endless pit of possible technical and mechanical problems drum scanners can have. For example, drum scanner image intensifier tubes must be matched, kind of like matching transistors in a high-quality audio amplifier. If one goes bad, good luck finding an exact characteristically matched replacement. And because image intensifier tubes are vacuum tubes, they can color the signal, to use another audio term. The nature of a vacuum tube-based amplification system is going to give you non-perfect results. Unlike audio, where tube amps can subjectively make things sound better, a photomultiplier is just going to add noise to the signal. Also, vacuum tubes wear out over time and change their characteristics, thus giving you different results. What about the analog to digital converters? Those are solid state, but they're still completely susceptible to the electronic interference that exists before the signal reaches them. And there's probably some interference since those photomultiplier tubes have to operate at really high voltages. Also, these scanners were made long before cellular networks, Wi-Fi, and Bluetooth were common, so there's another source of interference that these machines probably are not shielded from. A lot of drum scanners are not even using 16-bit analog to digital converters. They're using 12 or even 8. Ew, 8-bit color. How about the light source? That's going to wear out over time and produce slightly different results. And don't forget the mechanical aspects of wear. The issues just get deeper and deeper the more you look into it, and all of it adds up over the lifespan of these machines, degrading them further and further. Sure, they can be serviced and brought back to working condition. Regular calibration is very important for these machines if you want the best results, and that is what every drum scanning service today has done. They're all using these old machines that have been serviced to a working condition. I think at some point someone is going to make something 1,000 times cheaper and smaller that will give results on par or better than any drum scanner. And I think that's going to happen sooner than you think. That would put all of these drum scanner services completely out of business, which is kind of cool because you'll probably be able to get drum scanners that no one wants anymore for the cost of moving the damn things. They weigh so much nobody will want them except ex-drum scanner operators for nostalgic purposes and weird hobbyists. So what about the technical specs of drum scanners? Surely these must be super great. I've found that most drum scanning services are using the Heidelberg Tango drum scanner. Some are using a scanner from Aztec, Hell, or Dai Nippon, but the Tango is easily the most prevalent in the currently operating drum scanner service field. The spec sheet on the Tango says it can do 4,246 lines per centimeter, which it equates to 11,000 dpi. Now I got a problem with these measurements. 4,246 lines per centimeter is quite good resolution. And if you multiply that by 2.54 to get inches, you do end up with 10,784.84 lines per inch, which is pretty close to their 11,000 dpi equivalent. But that's the problem. They're equating line resolution to dots per inch. On a scanning device, dpi is basically your output resolution and is equivalent to pixels per inch. You may think, so what, that's the same. Well, the measurement lines per whatever unit, usually millimeter, is typically, in reality, line pairs per millimeter, and is a standard way of measuring an imaging system's detail resolving power. It's like a measurement of frequency in audio, and the DPI would be the sample rate. And so you of course need the Nyquist rate, which is 2 times the frequency, in order to accurately resolve those frequencies. I think the Tango is the only scanner I found with this issue. Figures it would be the most popular one. It's nitpicking and probably some kind of documentation mistake, maybe, but the Tango's spec sheet is not measuring in line pairs, but actual individual lines, which is absolutely not standard. Every other drum scanner spec sheet I've found lists only DPI, or points per centimeter, not lines. That means the max possible detail resolving power of the Tango is something like 200 line pairs per millimeter. I think they may have been using lines as a bit of a marketing method. The Aztec Premier says it can do 16,000 by 8,000 dpi. The Dai Nippon Screen SG8060P Mark II can do 12,000 dpi. The linotype Hell S3900, which I guess is also owned by Heidelberg, says it can do 10,000 points per centimeter, which is the equivalent to the listed 25,000 dpi. As you can see, these are all kind of in the same ballpark of 10 to 16,000 dpi, except for the Hell S3900, which seems to be significantly better, or maybe it's just another BS number, because I've seen people say it can only do 13,000 dpi, and that's a lot more in line with other scanners of the era, and maybe Heidelberg just loves fudging the numbers. The Aztec Premier also tries to do some BS with its specs. It says it can do 64,000 dpi, but that's an interpolated value, not a true sample rate of the scanner. So you get the idea, these companies do like to fudge the numbers, even on a high-level professional or even scientific instrument like a drum scanner. Remember, DPI isn't really a true measurement of detail resolving power, it's more of a measurement of sample rate. But with a drum scanner, I'd say, or at least I'd hope, that it can likely resolve details of at least half their sample rate. Remember, the Nyquist rate for a given frequency is double that frequency, so no matter what DPI a machine is rated at, it will only ever be able to truly resolve half of that rating in true detail resolving power. At 10,000 dpi, you would be dealing with approximately 200 line pairs per millimeter, which is the rated resolution of Kodak T-Max 100. That means the Heidelberg Tango should possibly be able to achieve almost a sub-grain scan for a frame of T-Max 100, assuming it is actually capable of truly resolving 200 line pairs per millimeter. Sub-grain, meaning more than 1 pixel, is representing the smallest details the film is capable of resolving. Assuming that detail is aligned with the grid of pixels, you would obviously need more pixels to represent something that is not in line with the pixel grid. You may think this is still unmatched resolution, and yeah, I guess it is. But on the Tango, and probably other drum scanners, there is a big flaw. According to Alex Burke, who has a drum scanning service using the Tango, the scanner is only capable of outputting 16,000 pixels per rotation of the drum. So if you're scanning something that is 16 inches around the drum, the best you could ever get is 1,000 dpi. This is probably some stupid limitation of the 90s computer memory modules, but if you're dealing with a 35mm frame, which is 36mm on its longest side, that would come out to almost exactly 16,000 pixels at 11,000 dpi, just barely under the scanner's max pixel limitation. So once you start scanning bigger film formats, you gotta step down the DPI, and that quickly becomes a huge disadvantage. The whole point of a drum scanner is that you should be able to get ultra high resolution scans of any size, especially large format stuff. The Tango is limited to scanning 8x10 film at under 2,000 dpi. 120 film would be limited to about 7,500 dpi. Now, I'm totally sure this is just a limitation of the Heidelberg Tango. There are probably tons of drum scanners that don't have this problem, and maybe Alex Burke is just wrong about this too, like, why couldn't you just tell the scanner to make multiple high DPI scans and then stitch them together manually later in Photoshop? But I don't know, and just finding the data sheets that I did find was an ordeal. I had to basically learn German for a day. There is practically no good technical info on drum scanners on the internet, and do you think the manufacturer is going to make the flaws of their super expensive and niche products well known and documented? Drum scanners can scan at a pretty high resolution, and I'm sure their detail resolving capability is somewhat equivalent to half their output DPI, ignoring weird issues like the Tango's limit. Drum scanners probably do give results that are higher resolution than anything else that currently exists. But at what cost? A drum scanner's resolution is really limited by the size of the point it's sampling, that being the aperture of the microscope. Drum scanners can't resolve details smaller than that, which is usually just a fixed size. Any details on the film smaller than the aperture of the microscope will be averaged out into a single pixel value. The drum scanner isn't actually scanning the image as an image, it's sampling points of light to create a rasterization, and the size of the points is a limiting factor to the true detail resolving capability. Drum scanners are typically known for producing grainier images, and it's usually said it's simply because it's truly capturing the grain of the film. But I think drum scanners are kind of over-exaggerating the grain, or even adding to it. I've seen goofy-ass YouTube comments saying stuff like, "You could see the emulsion at 100% crop on this Dai-Nippon drum scan." Huh? I think a lot of the grain, and even issues with color on drum scans, is actually from analog interference or noise in the capturing system. The vacuum tubes are coloring the output in a sense, and actual color performance is a whole ordeal of its own. A lot of people running drum scanning services either don't care or are too proud of their expensive machine to consider that maybe the 90s negative inversion software it uses isn't doing the greatest job in the world. Yeah, sure, you can use Silverfast with a lot of drum scanner models, and that probably does a pretty good job, but like, how do you know? I'd say if you get drum scans done, get your negatives scanned in positive mode and do the inversion yourself, because you have no idea what the guy doing the processing, or just pressing the buttons on the computer, is gonna do to your photos. Nick Carver had a video on this where he got scans done from 2 different drum scanning services, and one place just couldn't get good color. Now, this isn't really a video to say you shouldn't use drum scanning services. I'm sure they do give great results, especially when it's people who actually give a shit doing the work. If you're trying to get the absolute best scan out of your fine art photograph, then right now, drum scanners are sadly probably the only real option besides consumer flatbed scanners or equally ancient dedicated film scanners. So why aren't new drum scanners being made anyway? Well, I think the photo multiplier tubes are one big reason. No one actually knows how to make these things anymore. They use exotic materials. It's the same reason why night vision goggles cost so much. It's kind of like lost technology, and even then, why would you want to deal with them in a new machine with all of their flaws? Another reason is that building what is basically a lathe that has to spin a tube that can be removed perfectly, squarely, without any deviation, is really super hard. Even making the drums themselves is probably a pain. Just 1 millimeter of deviation on the surface is going to be a major problem. And of course there's stuff like cost, size, weight, ease of use, speed, and a bunch of other factors. But the biggest one that I think most people don't consider is complacency. Photographers are stuck thinking that film scanning technology peaked in the early 2000s. You will still, today, see people preach that the Nikon Coolscan is the next best thing after a drum scanner. Those Nikon scanners came out in 2003, and they're just linear CCD scanners like a flatbed or any other film scanner, but they have autofocus, so they do make very good scans. Today, those Nikon Coolscans cost more than they were new because of this mindset. There's also virtual drum scanners, which are newer, but they are the exact same technology as a Coolscan, linear CCDs, but these ones move the film over a glass tube, so they get to market themselves as fake drum scanners. In the mid-2000s, there was a massive push to digital from consumer product manufacturers. They wanted so bad to try and kill film photography, but failed with people who actually give a shit. It wasn't till like 10 years later when consumer digital imaging really started producing good results, but at the same time, the film photography craze reignited with amateur photographers, and today there are probably more people shooting film at a high skill level than ever before. But during that digital dark age of the mid-2000s, the development of scanning technology ceased. The drum scanning tech of the 90s was so good that average computers couldn't handle the files. That Aztec scanner that came out in 2003 apparently could do scans up to 96 gigabytes. Back then, the biggest hard drives in existence were maybe 200 gigabytes, if that. Lab scanners did somewhat continue development, and those could do a really good job scanning too. Lab scanners were more for volume processing, grandma's disposable camera vacation rolls, and getting enough quality to do typical print sizes quickly and efficiently. The photographers of this era got into a crystallized mindset that scanning was good enough, and that there is no reason to go bigger. Even today they still say this. And if you're talking about printing, it may be true. When printing a photo, which is intended to be viewed from a realistic distance away, you probably don't actually need higher resolution than what existed back then. But these photographers are stuck in that mindset. They don't understand the modern digital age. They think, any size scan of a negative is good enough to share on social media. They're like neo-boomers, and they're wrong. Not only do people today want a way to digitize negatives for high-level edits on the computer, they also want them for storage. A 10GB uncompressed TIFF is nothing today when an 8TB hard drive costs like $100. And why would you want to only store low-resolution scans of your film? Modern photographers want a digital copy, and they want that copy to be as good as possible. It isn't about printing anymore, it's about digitally storing a negative, and being able to edit that negative to get the absolute best possible outcomes. Yes, there are diminishing returns at some point, especially since most lenses can't even reach the detail resolving capability of film, but modern photographers want the best they can get, if they can get it. And sure, tech specs and megapixels are not what makes art good. You can produce fine art using a Game Boy camera if you want. But having the option is what's important. The option to edit those scans, the option to store those scans at high resolution, digitally, in case something ever happens to your physical negative collection. Drum scanners could provide this option, assuming you don't mind their limitations, but they're so cost prohibitive that most people today are resorting to taking a photo of their photo in the form of camera scanning negatives. Obviously, drum scanners can give you good results, especially in the hands of someone with a lot of experience working with them, but the fact remains that they kind of suck in one way or another. Not to say that every other method of scanning film doesn't also suck in their own unique ways. I have a whole series on how to properly use a flatbed scanner because flatbeds also suck so much you need years of research to understand the intricate ways of getting the best results. Imagine the hellish process of learning how to get good results on a 20-plus-year-old drum scanner. Scanning technology today is just at a low point right now, and hopefully sometime in the future that will change for the better. Like, I have some ideas of my own for some new scanning technologies that would be affordable for the average photographer, while also giving good results, hopefully on par or better than a drum scanner. So if you like this video, then subscribe. I upload new videos every week, mostly stuff not related to photography or scanning, but still cool videos nonetheless. And go follow me on Instagram too if you want to see cool film photos of my cats.